My name is Muhammad Nabil Alanik, student ID 522 121 50698. Today I'm going to demonstrate my final year project 2. Okay, let's begin. So the first attack that managed to succeed is brute force attack. So how I perform my brute force attack is through burp suit. So burp suit is going to be my main tool for this penetration testing. Okay, so the first step is I try to capture the request made from this site to the server, and then after I captured the request, I send the request to intruder for the attack. So what intruder does is intruder perform the brute force attack through the payload that I have loaded here. So this payload came from from various sources. Alright, let's start the attack. Okay, request number 21 is exceeded. This generally means that the website is vulnerable to brute force attack. Session copy. As you can see, I have bypassed the login authentication through brute force attack. So next vulnerabilities that I'm going to show you is the broken access controls. So the first step to my attack vector is to test the delete functionality. From this function, I have found that the referral header is exposed, which means I can manipulate the ID from this section and delete it from the database. Right, as you can see, booking have been deleted. So I can further this attack vector by capturing the request in the from burp suit. Right, from this post request, I can exploit it further by manipulating the ID. Okay, next. If you see it in the database, the data have been deleted from the database. This means that broken access control does exist from the site, and it can be exploited by the attacker. The third attack vector that I want to show is the host header injection. Alright, so this is the request made by the client to the server. send it to repeater. First step is testing if host header injection is viable. Okay, let's put some random strings here, and let's study the reply. Let's study the response. This means 200 OK. So even though the host is not correct, but the server still using the local host as the host. So what this mean is I can manipulate the header and bypass the login credentials. So I already get the injection code, send. Alright, as you can see here, the attack succeeded. Okay, let me prove it. This is the link. Right, I managed to bypass the login authentication by injecting malicious code or curated command. So from this, I can exploit this this functionality by deleting its booking with the existed broken access control vulnerabilities. Right, as you can see, the data has been deleted. This is the prototype site that I have produced. This is using an Angular framework with ASP.NET Core as the backend. What first I want to show you is the validation of the SSL certificate. As you can see here, the SSL certificate has been set up, and now let's debug the project. It is written in TypeScript or JavaScript. Okay, so the server has response. Okay, it has directed us to this port number. Let's open it in Chrome. Launching the SPA proxy. SPA means single page application, which is implemented by default if you're using an ASP.NET Core, which came as a package. Okay. Beforehand, let me explain the DBMS of the prototype. So what holds the database is the container from Docker, and the database is set up externally by Azure Data Studio, secured and easy to handling of the database, instead of implementing it in the web browser. Alright, so this is the prototype version of the website. As you can see, it is more responsive. This is why I opted to to use Angular framework because of the SPA. So let's demonstrate the same attack vector from this prototype. Okay, before that, let me explain few things on the secure socket layer validation. So as you can see, it has an padlock icon. This means that the SSL is validated for the web browser to use, and it is using HTTPS protocols for the connections. This means that the connection is encrypted with this encryption algorithm, SHA-256 with RSA encryption. Alright, so obviously after implementing HTTPS, the connection is secured. That means that it is secured from man-in-the-middle attack. As I showed earlier, from the original client side, it is exposed from head to toe. That's why I can penetrate the website, because the connection is not encrypted. So for this, for the prototype, I want to test the attack vector of the broken access control. Okay, let's try to delete. As you can see, the URL does not expose the deletion of the ID. So this means that the website is secured from broken access control misconfiguration. And of course, when you have a HTTPS connection, it cannot be intercepted because other connection is not allowed to connect with the prototype, because they don't have the validated SSL certification. Okay, as you can see, it is failed to connect to the prototype. This is due to the HTTPS implementation. Alright, so last thing that I want to talk about is the result from the Nmap scanning. Due to the security implementation, there is no way that I want to test. There is no way that I can test or intercepted the network. So I have to do the manual scanning from Nmap. Let's study this Nmap command. This is the prompted command for the Nmap scan. A for aggressive, which give the functionality to scan for OS, and SV for the version scanning, and the IP address, which is the local host. The first one is the first result is the port 80, which holds the client the old version of the website. As you can see here, the website is pretty much exposed from this nmap scanning, because from this information given, attacker can perform an OSINT, which is open source intelligence, and scan for any vulnerabilities that existed. So let's study the next port number that is viable to this demonstration. This is the prototype scanning results from nmap. The prototype is using UPnP service, and this is the HTTP request made by nmap to the prototype port number, which is running on 5000 and 5001. As you can see here, the SSL cert is located in the localhost. Also, it gave the DNS as the localhost. As you can see here, nmap made a HTTP request on the prototype, and the server response is 400 bad requests, which is this HTTP request was blocked by the server, and nmap cannot gain any information from this prototype server. Okay, next what I want to show you is the service fingerprint. All of this is the encrypted connection from nmap scanning. So nmap cannot determine what is the right service. Next security implementation that I want to talk about is the OAuth2 implementation, which stand for Open Authorization 2. Authorization begin when user click on login to the account. Okay, when user click login, the first process of OAuth2 begins, which is the client will send an authorization request, and resource owner will reply by giving the authorization grant. Okay, if we see in the console panel, this is the view from the console panel, invoking the first initiation made from client to access the resource server. This is the information given by the client to the resource owner, indicating the client ID and the required information. And then the resource owner will reply to the client back in step B for authorization from the client, invoking a login. Alright. Okay. Okay, after user has filled in the login, let's see the reply on the console panel. Okay, next step is next step of the process is the authorization grant will be sent to the authorization server, and it will send the access token back to the client. The first line, invoke the authorized combat endpoint, indicating that the authentication server received the data indicating that the authentication server received the authentication grant from the client. This information given here. Okay, the token issued success event indicate that the authentication server successfully issued the token. So the last process, which is the client, will then send back the access token to the resource server, and the resource server will validate the token and give the access to the protected resources. The third process begins here. Okay, as you can see, the client has been authenticated, and it can now use the access token to request the protected data. Okay, second line, which is here, indicating that the resource server received the token and validate it, returning the requested data. The resource server received the data containing the information of the access token, the token type, token value, and token is validated. After the token has been validated, the resource server now grants access to the protected information. As you can see in this line, invoking identify server endpoint, user info endpoint to connect. Alright, so that is how OAuth 2 process happens in the back end. Okay, when log out, this line appears, indicating that the end session request validation is success. Okay, that's all from me for my demonstration. Thank you very much.